Okay, so I have to find the angle between two vectors, and they're given to me as forces. I have a force 1 of 45 pounds, a force 2 of 60 pounds. I know that force 1 is on the x-axis, and force 2 is some angle with the x-axis, and they want me to find the angle between those two vectors. I do know the resultant force. So I have some vector going this way, some other vector going this way. I know the magnitude of the resultant vector, and I need to find that angle. So what is that angle? So first thing I need to do is, they tell me the resultant force is equal to 90, so that's a clue in terms of my equation, so I know I'm going to set it equal to 90. But I have to add force 1 and force 2. So let's first write them as vectors or linear combinations. So if force 1 is 45 pounds on the x-axis, force 1 could be thought of as 45I, could also be thought of as 45I plus 0j, if you like to have the j part there. Force 2 is at an angle, and I know force 2 is 60, so it is really 60 cosine theta. I don't know the theta. I plus 60 sine theta j. So that's how I write force 2 in terms of a linear combination. Now, I need to find the angle between, so I really need to add F1 and F2. So I have to find F1 plus F2, and then I have to find the magnitude of that. So how do I do that? How do I add these two vectors? Well, they're both linear combinations, so I can just add them. I add the I parts and the j parts. So that's easy. So this one is 45 plus 60 cosine theta, and that's all the I part, right? And then let's add the j parts. Well, 0j, so plus 60 sine theta j. There, I have them added. Now, how do I find the magnitude of that? Because the magnitude of these two, the sum of these two vectors, has to equal 90. You know how to do that, right? So, the magnitude of that, square root. You remember how to do this, right? So I have 45 plus 60 cosine theta squared plus 60 sine theta squared, right? The magnitude is this squared plus this squared. Oh boy. But you know how to do FOIL, right? So when you FOIL this side, again, still equal to 90. All right, don't forget that 90 there. So when I start squaring that mess, I get 2025 plus this times 2, which ends up being 5400 cosine theta plus 6 times 6, 3600 cosine squared theta plus 3600 sine squared theta. Now, I can get rid of the cosine squared plus sine squared because I know if I factor out the 3600, sine squared plus cosine squared is 1. So, I can get rid of that part. And let me clean my board and I'll be right back. Okay, so I cleaned this up a little bit. We've got the 2025, the 5,400 cosine theta, and 3,600 is 7,200. The cosine squared plus sine squared was 1. We factored it out, so 1 times that is still that. Now, let's get rid of the radical by squaring both sides. So 8, 1, on this side. And let's add like terms. So what happens when I add these two numbers together? 7, 8, 9, 2, 2, 5 plus 5, 4, 0, 0, cosine theta. Now let's move this over. So 5,400 cosine theta equals, and you can use your calculator to simplify that, 2475, check my arithmetic. Again, continue to solve for cosine theta. 2475 over 5400. So theta equals, if I do this out, I get 0.4583, which comes out to about 62.7 degrees. There's the angle theta. So, a little bit tricky, but you can put things into vectors and add them and find magnitudes. Good luck with the homework. Bye.